All right. So I just want to clarify a couple things from the last video real quickly, and just show you a couple other little quick things that kind of have to do with Things Pro. So basically, you should note that anything you do in Things Pro appears to overwrite anything you were to do in the Moxa via the command line. So just one of the things I just wanted to show is if by any chance, let's say you were not able to get Things Pro installed or anything, which you will be able to because it's quite simple. But, or if you didn't want to, or for whatever reason, there's a lot of configuration options that are going to be shown in the Moxa Debian 9 user manual. So that's on the Moxa website. I showed you this before. If you type in the device, which is the UC-8112 MET, we go here, and it's going to be in the Linux manual. This is the Linux user manual. So this explains all the Linux commands and what you can do with Linux itself. That's basically all you're going to need to operate the Moxa without using Things Pro, such as configuring network and doing this type of stuff. Now, what I just wanted to show is if you type in this command, I put this in here, but you type in cd / so you want to go to this etc. Directory and to the network directory that's inside of that. By the way, if you copy something like this and you want to paste it in here, and if you press Control V, it's actually going to type that in. It's going to type Control V in. You don't want that. If you just right click on your mouse, it pastes it. So anyway, so you hit enter. Now we're in this directory. Now if you go sudo nano interfaces and type in the password, then you can actually change the configuration of the Ethernet ports in this file by just changing them. Now, as you can see, these are the default IP addresses. And so when I changed them in Things Pro, it didn't actually change this file at all. But if Things Pro was not installed, you would have to go in here, and this is where you would change that stuff. Now, it's set to static right now. You would want to change this to DHCP. So it would be this iPhase F0 iNet DHCP, and then you could get rid of all this stuff here, and that would change it to DHCP. Now, if you were to do that, you would need to reboot the Moxa, and in order to do that, you would type in sudo reboot, and that's going to reboot the Moxa. And most network changes and things that you do from the command line like this, they do not take effect unless you reboot the Moxa. So that is just something to note. When you do them in Things Pro, you often do not need to reboot the Moxa. In fact, you shouldn't have to at all. But you might have to give it a few minutes. If you configure it in here in the network, give it a couple minutes. Maybe hit the refresh. It'll show up probably here immediately. It just might take a little bit to take effect. At least that's what I've noticed. It doesn't seem to be instantaneous. And Riley and I were messing around with some stuff in here, and we actually got confused. We actually changed we changed the port number that Things Pro was operating on, and I believe we did that. Somewhere it was somewhere in here, somewhere in the settings, and we did that, and then we weren't able to access Things Pro anymore. But when we typed in the IP address of the LAN port that we're connected to, which is how you access Things Pro, and then put a colon and put the port number that we had changed it to, we were able to get back on. But it took a few minutes to take effect. So at first we were like, okay, well that doesn't work, and we kind of counted that out, like, you know, typing in the port number here, and we thought, you know, that didn't work, but it does. You just got to give it a few minutes. So anyway, that's irrelevant. It's just important to note that things that you do in here usually take a couple minutes to take effect. If you do them from the command line in here, you know, that was just an example of changing the Ethernet IP addresses and the configuration for the Ethernet ports on the Moxa. But if you were to do anything in here, you will need to reboot. And again, if you do it from here, and you have Things Pro running, it will not take effect at all. You have to change it in Things Pro, because Things Pro overwrites all of that stuff, because it is the generic or default GUI for the Moxa. So anyway, okay, so that's that. Now we'll go back to our Moxa directory. Probably don't need to do too much in here, but just in case, we'll leave it open. So we'll go to Node-RED here. So now I remember I showed how to edit the JSON files that were located in here. In the last video, I showed you that. And I disabled them. Well, they're disabled here. That's what this little, you know, disabled icon means. So if you double click this and you go down here and you see it's disabled, you can change this, you can enable it. One thing to note as well is that you should probably make backups of your flows. So this is called a flow in Node-RED. And in order to do that, you just go here, export, and you just copy all of this here. You can copy to clipboard and just save it in a file. Just keep it backed up, because, you know, if anything does happen on the Moxa, or you do have to factory reboot, you're not going to lose all of your work. So you know, the other thing is that if you there's a way to enable projects on Node-RED. Now I don't have that enabled, and I'm not going to do it right now, because I think it can easily be figured out by whoever's watching this video. You know, there's a lot of documentation on Node-RED because it's an open source piece of software. So you just type in, you know, Node-RED projects, and you know, it'll tell you how to create a project, how to enable a project, how to do that. And when you create projects, it allows you to actually like publish them. Like if you want to publish your project to GitHub or you know, anything like that, and I think it'll allow you to create different flows, different projects, because otherwise Node-RED just will normally run whatever flow file is in here that I showed before. It's just going to run this flow file generically. But if you enable that projects thing in Node-RED, basically it's going to allow you to create separate projects with separate flow files and stuff like that. Now, I didn't do that. It's not necessarily for what we're doing, because like what we're doing is pretty simple. We're reading and writing to coils for well scheduling. So anyway, that's that. If you need to know how to do that, okay, go here. So one of the things I will show is I have backed up some of these files that I've made, some of these programs, and I'm going to import them. Before I import them, though, the other thing I want to say is that there are some situations that I've had where Node-RED has crashed and I haven't been able to fix it just by editing this flows file. Now, this usually works, like I said, but I think you know, potentially if you really mess things up, it might not work. Now, Node-RED, it has its own kind of backup. So it does kind of back your stuff up, but you know, I wouldn't rely on that. So if you were to open this flows file with nano, to edit it, it'd be sudo nano. So if you were to open this up and you deleted all of this, okay, so you can actually, if you hit Control K, it deletes all of it. Now, if I saved this right now, I'd have no flow file. I'm not going to do that. But if you did, and then you try to run Node-RED, it will back it up with like its last, its most recent, saved backup that it's kind of autonomously created. So I'm going to hit Control Z because I'm not going to save. I'm just going to exit that. Worst comes to worst, your best bet is to just delete everything in there, probably. But I mean, first try to disable things, try to change, try to get through that file. It's quite long, so get through it. Make sure your ports are configured correctly. If you see anywhere there's a port or an IP address, you can change it, and hopefully it's going to run. Worst case scenario, you delete everything in that flow file, or you can even copy and paste it from a flow file that you've saved, and then as a text, you can copy it and then you can paste it into there, or you could also you could just create it, and you could just call it flows_moxa.json and then just transfer it into the Moxa that way. You'll want to move it into here, but you'll want to move it into the right folder, the right directory, right? It's got to be in .node-red, otherwise it's not going to work. Now, I don't know if there's a way to actually show like hidden folders, because remember, this is a hidden folder. Not sure if there's a way to do that in here, but worst case scenario, you can move it over in here, and then you could move it. So the command is move, flows moxa.json, and you're going to move that. I believe it's first it's the file name, and then it's the file you're moving it to. So you'd put a space here, and then you'd move it into whatever directory. Like Moxa, which would actually be home Moxa .node-red. That's the directory of where we are. So you could do that. I believe that's the right command. You can easily look that up. Again, it's Linux. Everything's open source. Super easy to Google and find those commands. Yeah, I just wanted to make sure that that's clear, because if you do run into problems, I don't want you to be completely stuck. Sorry, I'm just drinking coffee here at the moment. Okay, so what else did I want to go over? I think that's about it in regards to that. Just back up your files, just in case, and maybe enable projects. I don't have time to do that because my contract is just about up here with the company, and I don't want to go messing around too much with that stuff and then not be able to just finish this tutorial and make sure it's everything's clear and understood. Let's see here. Okay, so the other thing is that you can export the flow file. Now you can export the current flow, or this is just the nodes. So like these are nodes. These are nodes, right? That's a node. That's a node. That's a node. So you can export just the configuration for those nodes. Oops. Sorry. Yeah, so and then you can also export just a JSON for the current flow that you're on, which for us is Modbus master, or you can export all flows as one. I recommend doing this and exporting them all as one and saving them, but also saving them individually. Just because, if by chance something is configured wrong in here, this is a much bigger file to sift through and find, the wrong IP or the wrong port or whatever it is. So yeah, I'd recommend just saving both. especially like, you know, save them periodically, and maybe, you know, once you've got everything sorted and you know, your whole program's written, then definitely, you know, just save it, just in case. Now, the next thing is I'm going to enable this, and I'm going to import some other stuff here. So I've saved them all. I believe these are up to date. So see, I saved them kind of separated. I saved them all as one, but let's see. Actually, one of the things, I'm just going to check and see which one's the most. I haven't been on here in a little bit to look at this, so I'm just going to see. Yeah, they're saved to my desktop. So I just want to. I'm going to open up my desktop folder, and I'm just going to see which one's the most recent saved. So we've got Modbus. Modbus masterflow March 11th, okay, yeah, so March 11th, that was the last time I saved them. So we've already got the master flow, and we've got read coils, I believe, yeah, and so let's just let's import write coils. So just copy that. And then go into here, import, paste it into there, and there it is. So write coils flow. You know, just a side note too, you can create like sub flows as well. Now I haven't actually done this, so I'm not 100% sure how it works. But again, just look up the documentation on that. I'm not sure how necessary they are. I guess it's just a way to create like a dependent flow, but there's a way to connect these flows anyway. So I'm not 100% sure on that. Just maybe have a look if you're curious. So this is our read floats. I'm going to import this. Our write floats. Okay. Now I'm going to enable all these. And there's another one that I made that I wanted to show for the MQTT stuff, but you know, I probably didn't save it because it wasn't what it wasn't the route we decided to go. But it would be nice to find that just so I can show whoever's watching this video that the MQTT with Things Pro does work. But I can just show you that. I can just show you that. It's really easy. It's really quick. So, all right. Anyway, so we've got our flows imported here. Now this is this Modbus master. This is just a combination. Basically of these, you know, some of these have different functionality. I wrote all these separately at first, just to test out each functionality, and then I kind of like combined them to do some other stuff. So, you know, at this point in time, I've done a lot of testing and stuff to confirm that this works and that we can do what we're trying to do, which is schedule some wells and control the choke valves. So let's start with this. So here we've got our read coils flow. Now I've modified this a little bit. So basically, I think it's probably best if I, instead of going through all of these separately, at first I'll kind of just explain how they work in here so that you can actually see. Now, these debug nodes are really important. So that's these guys here. Also, just note that if you go to node information, you just hit this little arrow, node information. It will, and you click on a node, it will explain what it does. Now, you can do that for each of them. Now, it's not always still clear to you, so it might be easiest to look up some documentation by performing a Google search or going on the Node-RED website and sifting through the forums. But for these debug nodes, they output a message that contains the payload of a node. So all of these nodes, just about all of them, they have what's called a payload. And the payload is just like the output. So you can think of that as like the output of a function, basically. And some of them, input, they need a payload inputted to them, and they will output a payload. Like, for instance, it's got 2 connections on it. So it will take in a payload and it will push out a payload. Now, some of them only take in a payload. Some of them only push out a payload. Because Node-RED is like written in JavaScript programming language, which is an object-oriented programming language, it uses this syntax. So you see it has message.payload.data. So basically what that is in object-oriented programming, it's how you kind of address an object. So an object is like I won't get too into it, but an object is basically like a container. And an object can contain things like variables, things like functions, and all sorts of stuff. So instead of just being a function block, it's a container. It's an object, and it can hold many different functions. It can hold many different variables, and each function can have its own local variables to the function, and all this kind of stuff. It just makes it's very powerful, and it makes for ease of use. It's quite cool how it works. But anyway, it doesn't matter too much, but it matters because basically the dot, the period, it is a way to access something in the container. So here, the output of this debug node is the message object. Now you can change this to the complete message object, which is, so when you view the output of the debug, it's going to give you like the entire object, which is, there might be extraneous information in there. Maybe there is, maybe there isn't. Maybe you want to see the entire thing. Or the other thing you can do is you can do message and then dot payload. That's going to show you the payload. Now the object can have a payload, it can have a topic as well, it can have some other stuff, and there's different levels. So like the message, think of this as like the first level, then the second level here is like the payload, and then this is like the third level. This is like the data inside the payload object, inside the payload object or whatever. Basically, I've got it set to this so that when I run this, now you want to go to debug messages. This is where it's going to show you what's output from here. And if you can turn these on or off. And when you do that, if it's off, you're not going to see anything. If it's on, you're going to see something. Now this is really good because if you had all of these turned on, you're going to get a ton of them, and then you're going to have to figure out where they all came from. So what we will do is we'll start with one thing. Now, let me just make sure everything's configured properly before I deploy this and have it crash on us or something. I'm going to do that in just 1 second. As far as that object thing goes, again, sorry, I might not have been that clear, but in order to address certain things, you use that dot operator. And so there is a way to view what is inside an object by having it configured to show you the complete message object. Now when it shows you that and you run this and something pops out here, you can easily see what's inside, and it'll show you the hierarchy. It'll show you the full, say the topic, which is maybe, the kind of the, it's like kind of the name of like the payload, or like the name of like the message that's sent from something, from a node. And then it'll kind of show you the hierarchy of like, it's like almost like a directory, right? It's going to show you like, okay, here's the payload. Now the payload contains the data and the address and this and that and the buffer and the input and output or whatever it might be included in the payload. And then so you would do like message dot payload dot data to see the data, or dot buffer to see what's in a buffer, or dot address, or dot unit number, or whatever it is, and then it will just output exactly that value. So anyway, very simple. So I'm just gonna make sure that this is all configured not to any weird IP addresses or weird ports. They seem to like to use 10.502 for the Modbus server. I'll talk about that after, and why. But you don't want to make this 502 because that is the same as the Scadapack, and it causes a crash. Again, not 100% sure why that is, but it gets confused when you do that. So. This would be this. Now, I don't actually have the Scadapack connected because I don't have an Ethernet switch, which is kind of unfortunate because I could better show the output and stuff and the input and whatever. But it's still not necessary. This is why I didn't try and get it shipped from Grand Prairie in the last week, because it's not really necessary. You can still see how this stuff functions and whatnot. I can actually emulate that as well. So now I'm just changing all the Modbus stuff just to make sure that it's like, there's no conflicting or strange ports or strange IP addresses. Okay, cool. So let's deploy this. Usually takes a second, especially because right now it's kind of deploying everything. Now this isn't going to connect because the Scadapack is not connected. I'll start. Okay, I'm going to start with kind of a top-down explanation of everything before I get too into it here. So, essentially how it works is you have these nodes and they output. Before I was saying how they output and input payloads, and that's typically what you're using. You're typically addressing the payload, but it's actually a message, and the message contains a payload. So, the message also contains other things as well. Not always though, like it doesn't have to contain anything else. It can potentially just contain a payload, which is actually kind of pretty common. Let's see here. So what I did, is to read the coils in the Scadapack. What I've done is I'm using this what's called a Modbus flex getter. Now, you can scroll down here and you can find it. This is it. And if you go to node information and you click on it, sometimes if you drag it, you'll actually get more information here. So it shows you how to configure it. It shows you, what the payload needs to look like and how it needs to be configured to write to a Modbus device. for write a single coil or this or that. And in order to configure a node, you place it and then you double click it, and then you've got kind of this properties window, and you can edit these values. We're using Modbus TCP, all this kind of stuff. And every node can be configured in that way, no matter what it is. So basically what we've done here is we've got this flex getter, and the flex getter is going to, just another thing to note is we want to use the Modbus flex getter, not the to read, sorry, this is reading, I think I said it was writing. We want to use that instead of the Modbus getter. Now, the Modbus getter, it doesn't allow communication for more than 10 nodes. Like it can crash and stuff. So I don't really know. I think the point is that it's maybe a little simpler to configure here, or a little more specific. But I wouldn't recommend using it, and everything that I've read and stuff says not to. So even though we don't have a whole lot of stuff connected to this, it's just easier to use this. This is a really good one. So anyway, this is going to read from our Modbus device. So we've got, this is the IP of our Scadapack 334. This is the port. Now you just configure that to whatever value you need. And when you click on this and you look at the node information, so it tells you what it needs as an input. And so it tells you here, it tells you the function codes that you need to read or write or whatever. Or sorry, this is all read. To read coil or read whatever register it is, right? And I think this kind of documentation, whether as to whether you're reading a holding register, an input register, or whatever, that's based on the device that you're using, and they should have that listed in the manual for the device, for the Scadapack or whatever it is you're trying to read from. So if you look here, this gives an example of what it should look like. So what the input to this read, this flex getter should look like. So this is the message that it needs to intake to be able to read from the Modbus device. So this is for a single input, and this is for multiple outputs. So you can use this format essentially. And so now, so this is the function code, right? This is where you would edit this, to be whatever you want. You would edit the unit ID if you want, and the address that you're reading from, and how many are you reading? Are you reading 10 coils or whatever? Are you reading 1? And then you've got a return message at the bottom here. Now, so what we got to do is we need to create a function node. And basically, I'm going to include all this code so that you can go through it while I'm going through the video, and you can take a look at it. You can pause the video, and you can, kind of go over this yourself and whatnot. But basically what I did here is I took that format that we see when I had clicked on this guy, and I took that format, and now what I've done, this is like a little bit of code in JavaScript basically. And so I changed the topic. So I created the topic basically. So I created a topic for, now you don't even really need this. You don't need this to read the Modbus device, but it will make it clearer in the future when you're debugging, where this came from, because you can check the topic and okay, it was the read, it wasn't the write that you're trying to debug or whatever. So you put this stuff in. Well, we want to read coil status, unit 0. We're starting at address 99, which in our Scadapack is address 99, I believe. But in Things Pro, it would be addressed as address 100. But you know what? That's completely irrelevant. Actually, no. You know, I feel like actually, I'm pretty sure address 99 is address 100 in the Scadapack. I think. But anyway, that's something that you can easily figure out, right? You just read and then see which one it's reading, simple enough. And obviously, I mean, I'm assuming the person watching this is familiar with the VMware and you know, how to view what is in the Scadapack for register values and coil values and such. So anyway, so you configure this to however you want. Simple enough. This inject node, basically all it does is it is sending a payload that's an empty string. And it's just basically triggering this to function to run. And then when this is pressed, it's going to trigger this, which is going to trigger this. If we look here, it'll give you a you know, an overview of what this intakes and what it sends. So it can return/send a single message object or an array of message objects and whatnot. And it explains like how to use it and stuff. But for our purposes, pretty straightforward. So also for this one, the output is the payload is a configured payload of the message. So whatever you want this to send out is what it's going to send out. And whatever topic you want to set, you can set that. And you just set it by doing this, message.topic equals, you use the quotations, and that's how you set a payload or a topic or whatever. With this node here, you don't actually have to write the code, you just type in the topic here. But if you wanted to address it, like say you wanted to address the topic from this guy here, well, you would do that by addressing it as message.topic. So you wouldn't set it to something. You'd say, like maybe you'd say, okay, you know, set message dot, and if you wanted to add a new like value in an object, you could say message dot value equal message dot topic, and it's going to take topic that was sent from this inject node and it's going to place it in here, basically. But I don't think that that's super relevant right now. So what we've done here is we've configured this. You can change the payload to be like an empty string or a Boolean or whatever. And you can actually schedule it to happen, you know, every 0.1 of a second. And so you'd hit this and then it would do that. You can have it repeat at intervals or at a specific time. So you can like change, you know, every day at this time, then trigger this read function. And, you know, it wants you to keep it under 596 hours, which I mean, I think is pretty easy because that's a pretty long period of time. So that's one way to schedule things. So if you wanted to schedule a well, for instance, you could schedule the right coil to happen at a certain time interval. There's also other ways to do it, which we can kind of get into. But if you wanted to set up other ways to schedule, you would need some different nodes. And you can find those, like if you do another Google search and you say like, you know, say scheduling nodes for Node-RED or whatever, and then you can find them and go, okay, and read about it, read about the documentation, read what it does, and then say, yeah, I want that. Well, then in order to get it, you just go here and manage palette and go to install and then just search for it. So like, because we have internet connected, say, oh, look, here's a scheduler, a Node-RED timer, or there's this package or this, and this is going to be like a package of nodes. And by package I mean like this is a dashboard package right here, and I downloaded this. This did not come like stock with Node-RED. I also downloaded this Modbus one. So this is like the package with all the nodes. So you can find another scheduling package, and you can download that and implement that as well. But I think this is a pretty good one to use. I mean, as long as you don't need to get too fancy with the scheduling, I think this has some pretty decent options here. So anyway, so I guess basically what I'll show you here is, now I don't have this connected, so it's probably, I'm not sure what it's going to output here, but if we hit this, and yeah, because this isn't connected, we're not actually getting an output here. But we could emulate that by creating a Modbus server. So you can actually go here, the server, Modbus server, and what we can do is we can make this guy, let's change this to say 11502. And what we're going to actually want to do is we'll want to change this to 10.10.10.1. So essentially what we're doing here is emulating a Modbus device. So this Modbus server here is going to act like a device, and it's really useful for testing things before you actually hook it up to like a Scadapack. So what we've done here, we've got 10.10.10.1, 1102. We're going to change this to 10.10.10.1. 11502, sorry. Yeah, that's what I put right. Yeah, and then we can take one of these guys. I'm just going to copy it, paste it, and we'll just see. We'll go to node information. We'll just see. So holding buffer output 2 is the coils. And discrete output 4 is a discrete. So we're going to be reading coils. So I think we're going to want to connect to the second output, but we could always like connect all of these too and just see, just in case. And let's just change it to the whole message just so we, make sure that we get everything. And we'll deploy this. And now I just want you to ignore everything from below here right now. Just ignore all of that. Just pay attention to this. This part right here, basically. Well, maybe including the server, this part. So now we can see it's connected. It says that it's active. So essentially it's going to be reading from what's in here. And actually, what we can do too is we can put this here, and we'll deploy that. And then if I hit this inject here, we're going to get a debug message. So it shows you the message object for each output here. So we've got the holding output, the coils output, the input, and the discrete. So like I was saying before, this is the hierarchy. This is the object. Inside the object, you've got the type. And then you've got this message that has a topic and a payload. And then it shows the payload as well. So you'd address these with that dot operator. So anyway, what we'll do here is we're going to read from this guy. So right now there's nothing in it. And I'm not sure. Oh yeah, so this Modbus response actually is another way to read that I forgot about. So we'll deploy that. And it'll show you here like the data in the emulated registers inside this Modbus server. So right now there's nothing in there. Also, one of the reasons that we're not getting anything when we hit this inject is because this is configured for message.payload.data, and there is no data object inside of this. So what we'll do is we'll take one of these, copy it, paste it, and put this here. So this isn't going to input it because this is the data object. That was something that was only included when I was actually reading from our Scadapack 334. Okay, let's see here. So we should be getting an output. I'm not sure why we're not. 10.10.10.1.11.502. 10.10.10.1.11.502. We should be getting something. Oh yeah, okay, so here it is. So now you can see that we've got, so this is the topic here, this read, that's what I set here before. This is the payload. This is the message object. And inside the object, it basically what it's saying is that this is an object. The message is of an object type. And so if we wanted to address that, like say we want to output the payload and we want to output the data, what we can actually do is, in fact, now that this is working, I actually think that this should have payload.data, because if you look, we've got a payload and then .data. This is the .data. So let's go like this. Let's try and redeploy this. Yeah, so you see what I've done here is I've addressed this message.payload.data, and now instead of getting that entire message object that we got here before, we're just getting the values, the data. Now if we try this one, we see that we get the entire object. So again, if you're debugging and you want to find something specific and you don't want to be kind of messing around and opening up all these little tabs, you just address it with this dot operator. So this is the payload, this is the payload, this is the data, and that's what we're showing here. Now if you change this to message.payload.buffer, then it would output this. So I think that that's simple enough to understand, and that's going to be huge in diagnosing issues. Okay, so what we've officially shown that we can read from a Modbus device. Now that's what we've done here. We've read from this Modbus device, which is just it's a virtual Modbus device. So what I'm going to do is I'm going to take a little break here, and then I'm going to make another video that will start off where we've left off here, and I'll talk about writing to a Modbus device, and then I'll kind of run through what the rest of all this stuff does. So thanks for listening.